Hey everyone, welcome back to AP Stats. I hope you enjoyed the little bit of gameplay at the beginning of this video. This is something that I do on my free time when I'm not, working on notes for your class or my nav math class. I love playing video games. I didn't have a lot of time to play video games while I was in college. So now, and while, I started teaching, but now that we're in quarantine and I'm a little bit more on top of my work, I'm able to get a little bit of gaming in. So if you want to play Call of Duty Mobile with me, go ahead and shoot me an email and I can send you my username so that we can play together. Today, when we finish up the last lesson of Unit 8, this is the last lesson that we're going to cover before we start reviewing for the AP exam. So make sure that you really pay attention and focus because most likely there's going to be a confidence interval question for the exam. And we're not going to know if it's going to be on means or proportions. So that being said, today's lesson is talking about confidence intervals for two sample proportions. We did confidence intervals for one sample means, for one sample proportions, for two sample means. Matched pair design was the launch. And today we're going to wrap up by doing two sample proportions. So let's get started. Let's start with the main idea. Suppose you want to compare the proportion of individuals with certain characteristics in population 1 and population 2, or compare the effectiveness of treatment 1 and treatment 2 in a completely randomized experiment. We compare the population or treatments by doing inferences about the difference P1 minus P2 between parameters. The statistic that estimates this difference is the difference between the two sample proportions, which is P hat 1 and P hat 2. To use P hat 1 minus P hat 2 for inference, we must know its sampling distribution. Recall from our lessons from Unit 7 on conducting hypothesis testing on two proportions. For that procedure, you use the sampling distribution P hat 1 minus P hat 2. If you have an SRS of size N1 from population 1 with proportions of success P1 and an independent SRS of size N2 from population 2 with proportions of success P2, then we knew the following would be true for sampling distribution P hat 1 minus P hat 2. So this part, I'm going to stop reading from the main ideas and just talk to you about what these things mean. This part, the shape, is talking about the conditions. Remember that we have to check P hat 1 or N1 times P1 times N1 times 1 minus P1. And same thing with our second size, and make sure that they're at least 10 or greater. We do that because we want to see if P hat 1 minus P hat 2 is going to be normal. So that part is our conditions. Okay. Our center, meaning the center of our graph, the middle of our graph, is given by P hat 1 minus P hat 2. And this part, this is going to be our point estimate. For our confidence intervals, this is our point estimate. Standard deviation, meaning how spread out our graph is going to look, is given by this equation, which is P hat 1 times 1 minus P hat 1 over N1 plus P hat 2 times 1 minus P hat 2 over N2. And we're using this one because it's a sample. Okay. So at the bottom of page 28, you get your equation on how to do a confidence interval for a two two sample proportions. And remember, these are samples, these are not populations, right? We don't know any information about the population. You have your template right here. And again, so this template is pretty much the same. The one thing we do need to add in, because it's a two sample, is our conclusion. If 0 is contained in the interval, this is something that we need to add to our conclusion. Since 0 is in the interval, we have no evidence of a difference in ... and this is in context to the problem. Okay. So I'm going to go ahead and start with the model problem. I'm going to show you how to do the model problem. You're going to do practice problem number 1 and answer the check for understanding for practice problem number 1 in Edpuzzle. Model problem. Who do you think are more intelligent, men or women? To find out what people think, the Gallup poll selected a random sample of 520 women and 506 men. Then asked about intelligence. 28 of the men thought men were generally more intelligent, but only 14% of women agreed, meaning 14% of women say men are more intelligent. Find a 95% confidence interval for the difference in men and women's opinion. So let's go ahead and start with our conditions, or actually, we're going to start with the name. The name of this test is a two-sample proportion Z interval or confidence interval. Both are totally appropriate. Conditions. We know that this is a random sample. It's less than 10% of all men and women. And now we're going to check if this is normal. Okay. So we're going to look at the number of people that say men are more intelligent and the number of people that says not men. So for men, we have 506 men times 0.28, which is 142 that say men are smarter, and 364 that say men are not smarter. For the women, we have 520 times 0.14, which is 73, which means that 447 women do not say men are smarter. Both of these are greater than 10, which means that this is normal. So we're good. Parameters. Let P1 be the true proportion of all men who think men are smarter. Let P2 be the true proportion of all women who think men are smarter. Moving on to the math part. P1, so our equation is P hat 1 minus P hat 2 plus or minus Z star times the square root of P hat 1 times 1 minus P hat 1 over N1 plus P hat 2 times 1 minus P hat 2 over N2. Remember that for a Z star, the sample size doesn't matter because we're just looking at the very last row where it's at infinity. and we're looking at a 95% confidence interval or confidence level. So Z is equal to 1.96. Go ahead and plug this in. So 0.28 minus 0.14 plus or minus 1.96 times the square root of 0.28 times 0.72 divided by 506 plus 0.14 times 0.86 over 520. You get an interval of 0.09, comma 0.19. But first, let's see how we do this in a calculator. You're going to go to Stat, you're going to go to Test, and you're going to scroll down all the way until you see two sample Z interval. You're going to use statistics because we have the values. We're going to go ahead and see how we do this in a calculator. So in your calculator, you're going to hit Stat, you're going to go to Test, and you're going to go all the way down to 2 prop Z interval, okay? Don't be confused by 2 sample Z int. Remember that we're looking at proportions, so we're doing 2 prop Z int. X1 is going to be 142 because 142 men say men are more intelligent out of the 506. X2 is going to be 73 because 73 women say that men are more intelligent out of the 520. Our confidence level is 0.95, and this is what we get, 0.09, comma 0.189. So that means that in my notes, I just rounded a bit. So conclusion. We are 95% confident that the differences in men's and women's opinion is between the interval (0.09, 0.19). Is there significant difference in opinions about which gender is smarter? Well, let's look at our interval. 1, our interval does not contain 0, meaning there is no evidence that so that means that we do have evidence for differences. And second, all these numbers are positive. So since the interval contains only positive numbers, there is evidence that more men think men are smarter than women. Okay. We're going to go ahead and move on to practice problem number 1. A consumer magazine plans to poll car owners to see if they are happy enough with their vehicles that they would purchase the same model again. Naturally, the question arises on whether or not American car owners are more satisfied than foreign car owners. The magazine collects a random sample of 450 owners of American-made cars and 450 owners of foreign-made cars. Suppose 76% of owners of American cars and 78% of owners of foreign cars would purchase another. Create a 95% confidence interval for the difference in American car owners and foreign car owners. So again, this is going to be a 2-prop confidence test or confidence interval. And we're going to start with our conditions. So this was a random sample. Is this normal? Well, for American car owners, 0.76 times 450 said yes. So 350 people said yes. For foreign car owners, 0.78 times 450, 357 said yes. For American car owners, 108 says no. And 99 said no for the foreign car owners. These are greater than or equal to 10. And there's a mistake here. Let me just do that math. So we have 0.76 times 450, 342. So this needs to say 342. Parameters. P1 is the true proportion of American car owners who would purchase another. P2 is the true proportion of foreign car owners who would purchase another. So let's go ahead and do the math. We have P hat 1 minus P hat 2 plus or minus Z star times square root of P hat 1 times 1 minus P hat 1 over N 1 plus P hat 2 times 1 minus P hat 2 over N 2. In this case, Z star is 1.96. So we have 0.76 minus 0.78 plus or minus 1.96 times the square root of 0.76 times 0.24 over 450 plus 0.78 times 0.22 over 450. So I get negative 0.075, comma 0.035. Okay. Before I do the conclusion, you're going to go ahead and enter in what your conclusion is for this problem. Here's the conclusion for practice problem number 1. We are 95% confident that the difference in American and foreign car owners that would purchase another is between negative 0.075, comma 0.035. Answer this question first. is 0 contained in this interval? If yes, what does that mean? Well, 0 is contained in this interval. Since 0 is contained in this interval, there is evidence to say that we do not have so there's evidence to say that there is no difference in proportion of American and foreign car owners who'd buy another. That is the end of lesson 8. I'm going to post a link in Google Classroom so that you can get the notes for practice problem number 2. Again, that's an optional video. You can watch it to get the answer, or you can just do it and then check the end of that video to see if your answer was correct. Next week, we're going to be starting our AP Stats review. I'm going to give you more details next week on what's going to happen. Hope you have a wonderful weekend. Rest up, and I will see y'all soon.